Okay, here we go. The first section is called graphing linear patterns. Okay, guys. I need to separate us?
No. No, I'm focused.
So, graphing linear patterns. So basically, a linear pattern, when we're graphing it, okay, is going to be on your coordinate graph any straight line. Okay, any line that you can get, it can go up or it can go down. Those are linear patterns. Okay, so basically the graph of a linear pattern is always going to be a straight line. And actually, when we're doing this, we indicate that it goes on forever with arrows. So the arrows at each of those represents that it goes on forever in both directions. We only have to graph a small portion of it, but that's just showing you where it's at, and then the line would go on forever in both directions. We can't graph that because we can't graph forever. Okay. So when we're looking at graphs of lines, there's a couple things to look at. When it's going up from left to right, so if it goes up from left to right, it's called an increasing pattern. It's increasing, and when we start to look at the actual numbers that go along with that, we'll see why it's called increasing. You can see, okay? When it's going down left to right, so it's kind of as you're reading it, it's called a decreasing pattern. Okay, so this one is decreasing. This one is increasing. Okay. So one's going up, one's going down, one is increasing in value. Basically, that's what it's saying. It's increasing in value. So it's increasing in value. Really what is happening is the y is getting larger as you go left to right. Okay, decreasing, it's decreasing in value. The y is getting smaller. Okay, so that's some things you can tell. You can tell if it's an increasing pattern or a decreasing pattern just by looking at the graph. If it goes up from left to right, then it's increasing. If it goes down from left to right, it's decreasing. Okay, so those are some things you can just identify with nothing on the graph. Like I don't have any points on the graph or anything. Just looking at that line, you know that's a linear pattern because it's a straight line. And it's going either up or down, okay? Increasing, decreasing. We'll talk about what a flat line is later, okay? That really tells us not much of anything. So that's the graph when we're looking at patterns, okay? The chart or the table, we can call it the table or the chart for a linear line looks kind of like this. I'm going to give you two different directions. So let's say y is equal to 2x. Okay, so basically if I put some numbers in for x, like this, if I put 0, 1, 2, 3, do the multiplication by 2. So 2 times 0 is 0. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. I'll let you guys get that written down. Okay, so I don't want to go too fast. Okay. what we want to do is, at this point, we want to have these going up by ones, up. So your x's right now, we're going up by ones. We might not always do that, but right now we want to put our points in, or our x values, as going increasingly up by 1. Doesn't mean you have to start at 0. You could start at 10 and go 10, 11, 12, just as long as they're increasing by 1. Okay? Now, if you look at this, do you see a pattern of how to get from one to the next? Yes.
Going up by 2.
It's going up by 2. Each time we are adding 2, adding 2, adding 2. Do you see that there's a 2 right there? When we multiply by 2, we are actually adding 2 each time. Because multiplication is just repeated addition. This just says, take 2 0 times. That's what that says. Add 2 0 times. Well, that won't give you anything. Okay, if I add 2 once, that'll be 2. Okay, if I add 2 twice, that's 4. So 2 plus 2. This is 3 plus, or 2 plus 2 plus 2, 3 times. So really what you have is 2, 2 plus 2, 2 plus 2 plus 2. And the term, the number there, gives you what you have, okay? So it's one of those sequence things that we can look at. But lines always do this. They always have a consistent amount that you're adding. So the pattern is always consistent, okay? It's a consistent number being added, or being added, yeah, to each term. So in this case, we're adding 2 each time. That is a linear pattern. When you see that it's always adding the same number, you know that it's a linear pattern based on that. Now this is, we're adding a positive 2 each time. So that means my y value is going up, correct? 0, 2, 4, 6, my y value is increasing. So this is an increasing, so you can look at it just to see what it's doing. Y is going up by 2. So this is an increasing pattern. Okay, so y is going up by -2. So looking at that table or chart, I can tell that it's linear because I see that it's increasing by the same amount. It's an increasing one because it's going up as you go up the y's. Okay. So if I'm looking at a different one, if I put y in and I put y equals -2x, I'm going to put 1, 2, and 3 in, 0, 1, 2, and 3 again. Why do I choose those numbers? We want to do a graph usually close to the origin, because otherwise we have to draw really big graphs. And so we try to do numbers that are close to the origin. Remember, the origin is 0, 0. So if I put x in as 0, that should be somewhat, we might get something close to the origin. Okay, we don't want to put big numbers. Okay, so here, -2 times 0 is still 0. Doesn't matter what I multiply 0 by, I'm going to get 0. -2 times 1 is -2. -2 times +2 is -4. Good review on multiplication by negative numbers. -2 times 3 is -6. They look similar to that one. What's the difference? Yes?
It's decreasing, not increasing.
It's decreasing. So what are we adding each time? We're
2.
We're adding a negative 2. So if we
Which
look at
means you're
this,
subtracting 2.
we're adding a negative 2 or subtracting 2. But because I defined it as a consistent number being added to each term, we are consistently adding a negative 2. Okay? When you add or subtract 2 or add a negative 2, then it's the y is going down, or it's becoming smaller. You look at it, negative 2 is smaller, negative 4 is smaller than negative 2, negative 6 is smaller than negative 4. Okay? So that is called a what kind of pattern?
Decreasing.
It's a decreasing pattern. And if I were to graph these two, because we know how to graph, we can make a table and we can graph them, what we're going to get is basically this. Okay? This is going to be 0, 0. It's 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 2, 3. Okay? So the first one is at 0, 0, then we go to 1, 2, then we go to 2, 4, then we go to 3, 6. Notice, oh my, great drawing. Connect the dots. Yeah. Well, hopefully you guys have better drawing than I do. Okay? Mine's a little wonky. Okay? But notice, from left to right, it's going up. That's because it's an increasing pattern. So it fits with our graph picture. Okay? Let's look what we have here. It's 1, negative 2, 2, negative 4, 2, 3, negative 6. This line, oh, a little bit better, is decreasing because it's going down from left to right. So our graph and our table or chart both show the same things. Because of this negative in front, it means it's going down because we're adding a negative 2 each time. So that's really what chapter 3.1 is all about. Okay, it's just looking at patterns, graphing them. These are considered always consistent, or it's a constant is another word for consistent. The constant that we're adding is right here. We added 2 each time. That's constant. It stays the same. Here we added negative 2 each time. That's a constant number that we add to get the next point. You can always use that when you're graphing. If you only graph a few, you can always use that. You know if I go over 1 more, it's going to go up 2. So you can always do that too to increase your graph. Okay. So, okay, yep. And then there's going to be review problems. Okay, so that's really all of 3.1. That's all it's talking about in 3.1 is looking at graphs of straight lines and tables of straight lines and how they are related and what the things mean when you're looking at those graphs. Okay. Now, let's go to 3.2. 3.2 is probably not my favorite section, but we're going to kind of do it. It's one of those things that I'm going to let you use Desmos on because I think it's much easier than you trying to figure it out the other way. Okay, so what we're doing is 3.2 is about solving a linear equation with a graph or a table. Basically, what we're doing here is showing you what it means to solve an equation, okay? Later, we're not going to use a graph and a table to solve these, because a graph and a table are not good ways to do it unless you have Desmos. Okay, we're going to figure out other ways to solve these. Okay, but this is what it actually represents, what you're looking for when you're solving an equation. Okay, so this is an equation. I don't like how they write it. What I would rather have is you get this formula, y equals 3x plus 2. That's a formula, okay? Now, what they're doing is when they're saying to solve one, what they're going to do is give you a y value. So they're putting in some number here that's a y value, and what you're trying to find out is what is the x that would give you that y value in this equation, okay? So they write it sometimes like this. 11 equals 3x plus 2, and they're saying solve it. Well, what that really means is that the y is 11. So what we really know is that y is 11, and then we're going to try to find out what is the corresponding x value. So if we were making a table, what x value would give me a y value of 11? Okay. Now you can do this by trial and error. Okay. Trial and error, I can actually kind of look at this and
Or you
see.
can divide.
Yeah, we can, but we're not going to do that right now. Okay. Does anybody, can they guess what x would be to make that true? Yes. 3, because let's check it. If I made x 3, that would be 3 times 3 plus 2, which is 9 plus 2, which is 11. So my answer to this is x has to be 3. It's the one that makes a true statement. Is there any other x that you could get that will make it 11? No, there's only one answer here. Okay, so so when we solve an equation, we are looking for the variable. You're looking for what, and I'm going to use x as a generic term for variable. Okay, you're looking for what x makes the equation true. So basically, you're just trying to figure out what value of x. This is kind of using a table. Now, the other way is to use the table and do 0, 1, 2, 3, 4, and see which one gives you 11. But that's a lot of work. We don't want to do that much work, okay? And so my thing is just look at the equation. For the most part, you're going to be able to tell it. If you can't tell what that number is, hence comes in Desmos. Okay, hence comes in Desmos, or if they give you a graph. So Desmos, you can actually graph the equation, and that's the equation that does not have the 11 in it. You would say y equals 3x plus 2. This is what you're going to put in Desmos, okay? Even if they said 11 equals 3x plus 2, you want to change that 11 to a y and make it y equals 3x plus 2 when you put it in Desmos, okay? If they give you a graph already, okay, and they have points on it, and they have that point right there, this is the y as 11, because remember that's your y-axis. So you go up to where y is 11, and you go over to see what the x value is of that point. This point here is 3, 11, so the y was 11. You want to find the x value, so you're finding the x value of that point. That's what you're really doing on the graph, okay? So when Desmos graphs it for you, it's going to give you something like, let's see, it's gonna go up kind of like that, okay? The nice thing about Desmos, go up to where it looks like it's about 11, okay? Go up and see where it looks about 11. You can scroll your line or your cursor up and down on that till you have exactly 11 in the Y, in the point, and it will give you the exact corresponding X value. So this is especially important when you can't find an X, a whole number X that goes in there. It's very much easier to go in Desmos and graph it, okay? If you're doing it without Desmos, the best you can get is an approximation. So I want you to go and actually practice with Desmos when you're doing the kind where it says graph the equation. Go ahead or solve it. In my opinion, graphing it is the best way to solve it because you're actually seeing what it's representing. It's representing the points that go together, the values that go together. Okay, and that's what you're looking at. Yes.
In Desmos, can you actually, like, you can put in the X, and then for the Y value, can you put in 3x plus 2, and it'll solve that for you, or do you actually have to
So-
put in?
Let's put it in this way. Let me show you. Okay, come up here so you can see. We'll get to a place where you can see.
Thank you, Grayson.
No, I can see your sign.
Can everybody see?
There we go.
Okay. Need to move because, oh yes, it works better if I can type. There we go, Desmos graphing calculator. Okay. We just want to go to the graphing calculator. Once you're here, that was one of them.
That's fancy.
Okay, delete. Okay, so here is where you type it in. The equation is y equals 3x plus 2. So I'm just going to go y equals 3x. I have to shift it to do the plus sign 2. Okay, notice it graphed it for me. That's as hard as it is.
So
That's
then
pretty
you can
hard.
go on.
So now I can go on to, whoops, I don't know why I did that. I can go on, see as I go up and down this, okay,
I'm pretty sure one works, it's only come with main black lines.
is it? No, it should work on all of them.
Maybe if you
If I click on it like that, so here the Y value is 0.52, I need it to be 11. So what I'm gonna do is not zoom in, I wanna zoom out, so it's the minus sign. So here's about 11. So I'm going to get up there, and that's 1106. Ah, right there is 11. It says 3, 11. Okay, so it's much easier to find. So you're basically graphing it. What I want you to do when you do it on Desmos, make a really quick graph, just show it goes up, okay? And then label the point, whatever it is, 311. Okay, that's what I want you to show. Because I want to see a little bit of things. So use a graph paper, draw the graph that it shows you. You don't have to draw much of it, and it doesn't have to be real accurate. But try to get the values correct, that it's about 3 over and about 11 up, so you can see that point. Okay, so on these, I really want you to mainly just use Desmos through the whole thing. Even if I assign problems that don't say that, it says use the table or the graph or whatever. Now, if it already gives you a graph, use that graph. Okay, don't reproduce it. Because it may not give you the equation for it. Okay, so it's just going to ask you what's the value.
That's why you can make your own equation that matches it.
Yeah, if you want to, but it's much easier just to look at the graph that they have a picture of. Yes.
Are you able to substitute x for 3 and that would give you just a point on there? That would be 311.
If you put 3 in for x right now, I don't know. Let me see this. I know you can do points somehow. Let me think how you can do points. I think if you go, let me see. I'm trying something. X,
What was your question?
comma, 11. Oh, it's just gonna, oops, not. It's telling me right now that it's not gonna tell me what X is. It says you don't have a full point there. Okay, so no, what I would just do is the easiest, and why I like it when you go along here is you're figuring out that you're actually finding a point on the line. And I like that better, okay? It's not hard. It tells you the points. You don't even have to estimate because it gives you the points on there. You may have to click on it when you're on the line up close to 11, just click on it and it will probably give it to you, okay? So I think as you play with this more, we're gonna do some, actually, does anybody have a computer with them today?
I do.
You do?
We can easily get a computer that's over.
Yeah, well, as long as we have one per pair, so you guys.
I mean, I have disposable.
It'll be fine here.
Oh, okay, if you wanna use Desmos on your phone, you can do that. Okay, yeah. So we're gonna practice doing some of that today in class because I think it's real important that we do, okay? Okay. Right now, I'm gonna stop the video. We have covered everything.